All right, ladies. You are, if I'm not mistaken, collecting data on the mass and the force of tension. You're going to get data points, right? You should get 8 of them. Sound good? Okay. How do you analyze that, right? You make a graph. That graph will have force tension up here and mass right here. And I might expect that if there's no mass, there would be no force of tension while it's swinging. And I might expect that as the mass increases, the force of tension will also increase. How to analyze what that means. Now, when your pendulum is swinging through, your force diagram will have tension and gravity. The net force is the centripetal force. So your centripetal force will be equal to tension minus gravity. Okay? Now what you're looking for that force of tension. That's what you're graphing. So I'm going to rearrange this equation for force of tension. To do that, I add over force of gravity. So force of tension should be force centripetal plus force gravity, right? Now let's replace both of these with what we know, right? We know that force centripetal has another way of saying m times v squared all over r. We know that force of gravity is another way of saying m times g. That's equal to the force of tension. Do you see how there's a mass in both of these terms? Right here, there's a mass there, and there's a mass there. So I'm going to rewrite that equation over here. I'm going to say force of tension is equal to v squared over r plus g. From both of those terms, I pulled out a mass, so it's times mass. Now look at this. Y equals mx plus b. Your value of b should be 0, so that'll go away. Your x variable is the mass, so that's your x variable right there. Your slope should be this whole thing right there. Your y variable is the force of tension, right? Okay, so with your numbers, right, you've calculated what the velocity will be at that point. Solve, and you know what the radius is of your thing. Calculate what you would expect the slope to be. I don't know your numbers, so I can't calculate what the slope that you expect to be will be. And then when you make your graph, you should get a slope on your graph that is equal to whatever number you get when you do velocity squared over r plus g. Sound good? You can repeat watching this video. You can ask me questions. I hope that this clarifies things for you. That type of analysis definitely would be a high-level 4.0 analysis. All right, go get them.